Yeah, don't be shy. Come on up front. People in front seats get the best swag. It's around. All right, welcome to Cloud Native Madison 2. Very excited you all are here. Woo! So our first meetup was last month. We had over 50 attendees here, which we're thrilled about. It's always hard to predict how many people are going to get out based on RSVPs. But we were very thrilled to have that. These events are always going to ebb and flow, but I'm very pleased to see we got a nice turnout again here tonight. Want to again thank Google Cloud, who sponsored the first meetup, as well as ARMS Business Solutions, who's providing the space. ARMS is also providing the space as well as the food tonight, so thank you to ARMS for putting an investment into this great resource for the community. We put out a survey last month and we had 11 respondents, so thank you for those who did. I was told after the fact that we didn't have the link up there long enough for the survey, so I've posted it up around today. Please go ahead and fill it out. It's just a couple of questions. It's basically, what did you think of the content? Would you come again? We are going to expand it out a little bit more because we only put out that survey to attendees last time, and we have over 150 people sign up for the meetup group, and one of the things we definitely want to make sure we're doing is, trying to be in a location that works for the community. And so we're going to be looking for other places we can host this centrally or on the west side. So other companies, other organizations who are involved in this space, we'd love to hear from you. If you have a space that would work for us, if you think about sponsoring. But overall, like over 85% of the respondents, rated us a 3 on everything. So we're real happy with that. A couple of comments that, that really helped us out. People really liked that we live streamed this last time. I will say that we're unfortunately not live streaming this tonight because we have some live demos going on Linux laptops and we haven't quite figured out how to achieve that yet, but we're going to be working on that for next month. This is being recorded and will be put up on YouTube for posterity, so people will be able to review it there. We also heard from some people in the comments that they would like some more kind of direct networking opportunities, kind of like a, hey, this is who I am, where I work, what I'm interested in. And so we're going to be trying out something new tonight, kind of called like open topic spaces. So during the break between the first and second talk, what we've done is we've taken a couple of topics and we've just written them on a piece of paper and we've taped them up on the walls around here. So we've got running Kubernetes in production over here, we've got service mesh off in the back, we've got observability over by the fridge over there. So we'd really like to invite people to kind of coalesce around those areas during the break if you're interested in those topics. And there's no agenda, just try to meet some people from the community who are maybe trying to solve the same problems or thinking about the same kind of things you are. Have a conversation. If you've got a new topic, you're like, what is a Kubernetes? You can write that on the piece of paper over there at the end of the table. Tape it up on the wall somewhere. See if somebody wants to come over and have a conversation. Also in response to that, we did create, I'm getting ahead of myself here. So find a topic, great. Running Kubernetes in prod, training resources. So we also did create a Slack workspace for the Madison community here. And so the idea behind this is, we just wanted to have a way that people can communicate and, spitball ideas, talk about technologies you're using or maybe that you want to use even when you're not at this meetup. And so this is totally free. You can go out to slack.com, just, sign up for Cloud Native Madison. I did send out an email to all the registered meetup participants earlier this week with a direct link to go sign up. But there's no barrier to entry here. We've already got some activity there. So I'm really excited about that. We've got a channel there for discussing topics. If there's something you'd really like to hear be talked about, go ahead and throw a comment in there. Otherwise, maybe you're working through something and you just want to see what other people are, how other people are thinking about solving that. This is a great way to talk about that as well. Wanted to point out some upcoming local events kind of going on in this space. So I do want to plug the local Madison DevOps meetup group. Anybody been to the local MSN DevOps group? All right, awesome. It's a great group, and they've been going for years. I'm really impressed with how well they've been able to sustain that group. And so they've got a meetup coming up next week, operationalizing the development experience with engineer from LinkedIn. And so we just want to kind of cross-pollinate these two communities. There's a lot of overlap in these two spaces, and so we're trying to encourage everybody to get out to all these events so we can all learn together. The next is a vendor-sponsored event from Susie called Devon Hops. This is happening on the 16th, actually just up the road here by AmFam at Noah's event space. And that's sponsored by a number of companies you see up there, MongoDB, Snowflake, Sirius, StackRox. It's during the business day. There's going to be hands-on demos, vendor presentations, and then a couple hours of socialization with some beer at the end. So be aware of that. The link is there, but honestly, if you Google Devon Hops Madison, you'll find it. And then we're already planning for our next Cloud Native Madison May meetup. So I believe it's probably going to be in this space, but like I said, we're looking at other spaces more centrally, like Central Library downtown, to try to serve maybe members of the community who have a tough time getting over here after work on a Thursday by 6 o'clock. But we do have one speaker from Centera Systems queued up. Dustin Ewers is going to be talking about building cloud native ASP.NET Core applications for Kubernetes. So yeah, please, this is really cool. It's a great example of how diverse the cloud native community is, that in the third meetup we're already talking about building Microsoft stuff for Kubernetes. I love that. So I wanted to take a quick moment, and maybe this will prompt some of the kind of open spaces talks, talk about what's just happening in the community in the last month. A couple of exciting things have been going on. So Kubernetes 1.14 was released. A couple of cool features that came out with that. So they've graduated to GA the Windows Server 2019 support for worker nodes and running those containers on those worker nodes. So that's really cool. You can bring even more workloads onto Kubernetes now, no matter what your ecosystem is. They've extended support for kube control. I'm going to go with kube. Some people call it kube cuddle. I don't like to cuddle with my tools. It's a good way to lose a finger. But this is a really cool mechanism, and there's actually a really interesting number of plugins out there for kube control to do things like tail logs from all of my pods behind a certain service instead of just one. And so it's cool to see that kind of graduating. Another one is durable local storage. So the idea here is that obviously if you're running in the cloud and you're running on something like EBS volumes in AWS or whatever the analog is on your cloud provider of choice, that obviously there's a network hop between you and your storage. And so if you have some really low latency needs as far as your Kubernetes workloads, this will now give you the ability to work on very fast local storage, whether that's spinning Rust or SSDs, and allow you to just provision that like a persistent volume like everything else. So really good to see that go in. And the last cool feature in 1.14 is pod priority and preemption support. And so the idea here is, before this feature, you could basically kind of guarantee resources by setting pod resource requests and limits to be the same. But beyond that, the Kubernetes scheduler, when under node pressure, would just kind of kill whatever pods were kind of using the most resources. And so this gives you a way to say, no, this class of pods is actually more important than these other ones. So if you have pressure within the cluster, you can now set up which ones you want to kind of kill first. And so that's good to see coming out. Istio 1.1 is released. Has anybody heard of Istio? I can't imagine. Istio, are you doing a talk on Istio later? I might be. Okay, we got to talk on Istio later. Well, see, this is already out of date. This is how quickly it moves. So cool stuff coming out in that is a lot of enhancements for supporting multi-cluster. And so, the idea here is that Istio typically has worked in a way where all of the great features for observing, securing, and doing like reliability engineering, doing request retry and that stuff, is typically kind of ended at the border of your cluster. And so what this will allow you to do is have any number of different Kubernetes clusters where you can kind of extend that mesh out into them. And so you can bring all those features across. Let's say you're doing a hybrid cloud and on-prem kind of application architecture. Or maybe you say, it makes sense for me to actually isolate teams or applications into their own clusters. Now you can bring all those service mesh features into play without having to kind of go all the way out to whatever your first point of ingress is and come back into those clusters. You can just kind of go horizontally into them. So that's really good to see. They've also deprecated ingress, which is really still a moving target within Kubernetes in general, I would say, in favor of ingress gateway, which is kind of their new way of doing things. And several performance improvements. I was really impressed by this. So what this basically is saying is that they've reduced down the average latency to like 8 milliseconds to send a request through that mesh as opposed to not using the mesh at all. And so it's really good to see them really focusing on that performance, because we want to use all those features without having that any sort of performance penalty ideally. And so that to me seems like a very palatable penalty for getting request retry, observability, and extra security into our applications. Open tracing and open census are merging. So this is exciting, and it's something that's still pretty nascent in the community, but I can speak as somebody who's sometimes seen the builds for our application performance monitoring tooling, and this is really exciting to me because this kind of presents an opportunity to have more open tooling and tooling that developers can put right in their application to do the kind of things that a lot of companies are paying a lot of money for these days. But the idea here is that you instrument your code, every single transaction that flows through kind of passes along some headers, and then you can visualize that in the tooling of your choice. The other exciting thing about this is that open tracing was really focused only on distributed tracing, whereas open census kind of broadened the scope a bit and brought in metrics and logs in addition to that. And so they're really kind of pushing towards an open metric log and distributed tracing protocol and framework. And so I would expect a lot more tools to be popping up in this space once this merger happens. And again, just giving us more tools we can jump into right away without going through contract negotiations and paying somebody a lot of money. There's an article on Medium about this out there, if you'd like to read more. And finally, there's a new open source foundation out there specifically around tooling for the continuous delivery activities that most of us are probably doing if you're in the cloud native ecosystem. And so this is another subchapter of the Linux Foundation, the Continuous Delivery Foundation. And initially they've adopted Jenkins, Jenkins-X, Spinnaker, and a brand new project called Tekton under that umbrella of the Continuous Delivery Foundation. And so most of us are probably familiar with Jenkins. Jenkins-X is kind of a prescriptive Jenkins plus other tooling stack, so that if you want to target Kubernetes for your applications, but you don't really have an existing pipeline to build, test, and deploy your stuff out there, this kind of gets you going without having to think about it too hard. It's kind of a best of breed stack of stuff to do all that for you. Spinnaker is a tool that came out of Netflix that is only focused on delivery. And so it gives you an interface and a framework by which you can do canary and blue-green and other advanced style deployments. And it's been very popular in the community for a long time. And Tekton is something brand new from Google that I'm still getting my head around, but basically what it allows you to do is define your pipeline using native Kubernetes resources. So the same way you might define a deployment, you might define a deployment task or a build task or essentially a Kubernetes job to do this for you. And so the idea is that you have more native integration with Kubernetes in your CI/CD pipeline. So that's really exciting. In fact, this is so exciting, and frankly, cloud native it's getting a little long in the tooth. Frankly, we've been doing this for like 6 weeks now. We here at Cloud Native Madison are so excited about this that we've decided this is old news, we're rebranding. And so I'm very excited to announce to you today, we are now rebranding the Cloud Native Continuous Delivery, and why not? Here's some magic pixie dust, Madison. We're gonna need new stickers. I do want to mention, we didn't really do a good job of communicating this at the last meetup, but we are going to be joining anybody from the community who would like to continue the conversation after the meetup at Mr. Brew's Tap House just down the road here. So if you'd like to continue the conversations, come do some more networking after that, please come join us. Come as you are and stay until you're done. With that, I'll introduce our first speaker for the evening. Steve Lowery is an engineer here at ARMS Business Solutions, and he's going to talk about Java memory management Kubernetes. So please give a warm welcome to Steve Lowery.
Testing. Can you guys hear me? Okay. Let's see if I can figure out which tab. Oh, I got it. All right. Hopefully I can figure out this clicker. Okay. So the title of my talk is Taming the JVM Memory Beast. We're going to talk about basically, we've been on Kubernetes for about 5 months. Talk about some of the pitfalls and lessons learned from our organizations moving our Java base, which is primarily what our workloads are, out into Kubernetes. So a quick survey. Who's currently running, you don't have to answer ABS employees because I know your answer. Who is currently running Java workloads in Kubernetes today? Okay, we got a couple. Who's interested in running Java Kubernetes workloads? Okay, some of the same people. Who's just here for the Istio talk and doesn't really care about this? Okay. A lot of hands not raised, so I assume the rest of you is here for free pizza and stickers. Okay, so I kind of alluded to, what I want to do is tell the story of the issues we ran into running Kubernetes, or running Java-based applications Kubernetes, what we tried, what worked, what didn't, and kind of where we're at today. It isn't meant to be prescriptive in telling you this is how you should do it, just more lessons learned. This is kind of the manual we wish we would have had when we got going to avoid some of the pitfalls that we did. So quick agenda, I'll tell you a little bit about myself. We'll talk about the problem we're trying to solve. We'll go through some terminology because if you're not fluent in Kubernetes and or Java, we're going to be throwing a lot of terms at you that you might not understand, so hopefully we can quick talk about that. And then we'll talk about our journey. A summary page that you can take a picture of, and that's all you need to take home to your organization if that's what you care about, and then hopefully there'll be time for questions at the end. So a little bit about me. I've been an engineer here for about 11 years. I went to the school up the road a lot more than 11 years ago. I've been an application developer for about 18 years, a lot of Java work. Been doing a lot of Jenkins work the past couple years. From a personnel perspective, I love traveling, love to drink tasty beer, love technology, but I hate social media. Okay, so what are we trying to solve? How do we make it easy for development teams to tune their Java applications without just over-provisioning and throwing a bunch of memory at the problem? So that's the problem we were trying to solve. So there's a lot of different ways to tune your memory settings in Java and in Kubernetes, so let's just talk about some of the terms. So a resource request, this is a Kubernetes term. You know, it's the amount of memory that the pod is asking for to be scheduled. So it doesn't have to do with how much memory the pod has available to it. It's just for the scheduler to be able to find a node to run your workload on. The resource limit is the maximum amount of memory that that container can have before Kubernetes comes and kills it. This is the rest are Java. This is the max heap size. That's the amount of memory that the Java heap will take. The maximum amount is allowed to take for the Java process running inside the container. Java 8, update 131 and above, they introduced this parameter called max RAM. So max heap only accounts for the heap space memory. Max RAM accounts for all the memory that Java can take. So that's another knob you can dial to adjust your memory settings. And also they introduced max RAM fraction, which we'll get into a little bit more, but that's all, you're able to tune how, like a fraction of the total RAM used, how much of that should be used for heap. So obviously you can see there's a lot of different ways you can configure memory. So we'll talk about how we configure our journey to where we started and where we are today. So like I said, 5 months ago, we started deploying stuff to Kubernetes. So any of you who've done Kubernetes, this is a snippet of the manifest that we're using. So does this have a laser pointer on it? Yep. Is it the red one? Yep. So you can see we were allocating 256 meg a request and a limit of a gig. Right? We were going to Kubernetes. It was going to be awesome. It can auto scale, so we can just ask for a little bit of memory, and if we need more, it'll grab more, and we won't have any problems. It'll just auto scale for us. So yeah, our initial, like I just alluded to, those were our initial deployments. Now, when we actually looked at these workloads, most of them were typically running about 500 megs of memory, so quite a bit more than what we were requesting. So after not that much time, after a little bit of time, we started getting a lot of pod evictions. Steve, what's a pod eviction? So if you request too little memory for your Java workloads, the node is going to be under too much pressure, too much memory pressure, and it's going to start, when it starts seeing that the node is running out of memory, instead of having the node OM, it starts killing pods that are running on the node. And it has an algorithm to determine the best pods for eviction. Branden kind of alluded to, now there's this priority that you can say, you can tag so that it's a little smarter about which pods it kills. And we're not going to really go into the algorithm here. So I'll attempt to kind of visualize what's going on here. So say you have a node running with a gig of memory. Obviously your nodes would have more than this, right? So we run a couple of workloads out there. I put 3 workloads out there, again, with that same 256. Right, so that looks good, everything's happy, we're running at 256. We could probably even run another pod on this server, right? Well, if you've ever run anything in Java, it's going to start eating more memory up over time. And now you can see that the node is under resource constraint. So Kubernetes is going to, again, run through the algorithm and decide it's going to kill one of these pods. So what happens then? It kills the pod, right? And for a brief second, life looks wonderful. We have plenty of space back left on this node. But the replica set says, hey, this workload still needs to be run. Where should we run it? Scheduler, please put this somewhere. And the scheduler says, hey, look, I got a bunch of room. I'm going to run it right here. So then it reschedules it back on that box. And eventually it starts taking up more memory, and you run into an infinite loop of pod evictions. Now, it takes some time. It's not like this is continual churn of pod evictions, but we were finding a lot of our workloads were out there getting evicted. So what we learned was, to reduce the stress on your nodes and eliminate your pod evictions, make your resource requests and resource limits be equal. That way you're guaranteed to have that amount of memory for your workloads. So that's what we did. So we decided we don't want to do this dynamic 256, 1024. We're just going to throw more memory at it, right? The old verbiage. So you can see we changed it to use a gig each, right? We altered the deployments. No more pod evictions, yay. But now we spun up a whole bunch more nodes in our cluster to account for this. And our spend went really high for I don't know, a couple weeks. So we fixed one problem, but we caused another problem. Our customers were happy, but our management wasn't, because we were spending too much money. So we wanted something better. So we took pause to think about it. We wanted something where the Java memory parameters, right? We kind of talked about all those different dials, adjusting the heap size, adjusting the resource limits. We wanted something where we didn't have too many dials that the teams had to think about to configure. So we wanted a way for the parameters to update based on the limit set for the container. So we found that Java 8, again, the same version, introduced this parameter here, use C group memory for limit for heap, which sounds exactly like what you want it to do, right? Figure out how much memory the container has and use some ratio of that for your heap. That sounds awesome. And if you're doing it in Java 8, you have to give this additional parameter to actually enable it to work. And we talked about this. You can tweak these different sizes. So you can say, by default, it's going to use 25% of that memory limit for your heap. So if you allocated a gig, it's going to use 256 mega RAM for your heap size. You can tweak that to use a third or a half or all. All is extremely dangerous and shouldn't be used in any circumstance in production for sure. We played around a little with this 50 and 33%, but ultimately we found out that it didn't quite work the way we wanted it to. We were still seeing pods getting OM killed, and that the max RAM fraction was too rigid for us. Like we wanted to be able to fine tune it a little more without feeling like we were wasting memory and overpaying and over provisioning our workloads. So what did we do? So we just decided to try using Helm. We were already using Helm to deploy our workloads, so it seemed like a natural fit to update our charts to kind of dynamically generate these memory options based on the resource limits of the container. So I'll show you an example of kind of what we did. So again, we defined our resource requests. So these are our current defaults of 650 meg, and I'll go into details in that in a little bit. Side note, I know this is memory talk, but if you are going to run Java-based workloads, we're running Tomcat. You do see a difference in the CPU request and limit, and that accounts for startup time. Startup time for these applications, Tomcat takes a lot of CPU resources, so if you don't give it the resources it needs at startup, it takes a really long time to start up. So this accounts for that initial startup spike. So this is just normal Kubernetes stuff, and then we added a couple Can you guys read this? Good, because I don't know how to zoom in if you can't. Move closer if you can't. So we added 2 parameters here, max RAM percentage. So that was the percentage of the memory allocated to the container that we wanted to use for the Java process, total memory. And then what percentage of that did we want to use for heap? So we did some experiments. We built a Java application that we could pass parameters and it would just start eating up memory, and we played around with these. And for our types of workloads, which are primarily REST APIs, we found that these were good defaults. But with a Helm chart, these can always be overridden by anybody implementing it. So what does that end up looking like? Okay, so we have the values, and then here's our helper function. So I'll go through this line by line. But we're defining our limit. So that's that value. Again, this is Golang. So if you don't know Golang, hopefully we can kind of stumble through this and you can figure out what's going on. But we're just doing a regex to find the number portion of that resource limit, and then also finding the non-numeric resource limits, so the megabytes, kilobytes, gigabytes. And then we do our max RAM percentage, which is, we give a default of 80, which was the same as in the chart. And then we put some guardrails on there to protect, in case someone tried to override it and say, give me 100% of the memory for Java. Because that doesn't allow you to do things like shell into the pod and run an apt install curl to go test something on it. So we got to leave a little overhead for troubleshooting tools like that. And the heap, again, we don't want to use 100% for heap, so we put some guardrails in there. Do the division, do the math. It's really complex math operations here on these 2 lines. We talked about the unlock experimental VM options, and then so we specify the max RAM, the max heap size, and then I'll talk about this a little second. So this function then gives us some results that look kind of like this. So default. So I run the Helm template to see what it is. Is that the Oscar music starting up and telling me it's time to move on? Actually, I can see the screen a lot better. So just with that 650 meg limit that we chose by default, that gives us about that 256, so 260 meg heap size limit. So that kind of kept our workloads in line with what they were previously used to. And you can see if we bump the memory up to a gig, then that allocates 819 meg for Java, and of which 409 is used for the heap. We could say we want more heap. We want 80% of the heap, which that number stays the same, but then that increases the heap size. And this is just showing that doesn't have to be megs. You can use Ks, and it'll still do the math and convert the Ks out there. So that's the solution we currently have today. I'll talk a little bit more about this exit on out of memory error. This is an important one that we also kind of learned the hard way. So that switch tells the JVM whenever an out of memory error is thrown to exit immediately. Otherwise, the VM will usually still sit there and run and try to service requests as best it can. And we had instances where our liveness checks were running fine because they weren't having to do anything with memory. They were just returning a static, OK, alive type of message, health check. But any user request coming into the pod that would query a database and try to read some data into memory, there was no memory for it to free up, so it would just hang and return errors to the client calling. So when you put it there, it will kill the pod immediately, and then Kubernetes takes over and starts up a new pod in its place, and then you're not returning errors to your customers or your clients. A quick note about, we're running Java 8 workloads primarily. Java 10 and Java 11 kind of changed how they're doing memory management. They've deprecated the use C group memory limit for heap, and superseding it with use container support. And then they've also done, instead of being a rigid 1 through 4, you can now do it with a percentage number. Instead of the max RAM fraction, it's max RAM percentage, so a lot more flexible. So I'm sure if you were interested in doing something like this, it would be even easier in Java 10 or 11 because you have some additional parameters that make that easier to do. Okay, in summary, try to keep your workloads to have equal memory requests and limits. Remember to include that exit on a memory error switch. And then, find a way to reduce the number of knobs that can be configured so your development teams don't have to think too hard about how they should adjust. They should just turn the knob up or down based on the memory that they need and have some good defaults there to kind of guide them along the way. But I think most importantly is whatever you choose to do, whether it's Helm, maybe you just want to put it directly into your Docker images or have configure it in some other way. Observe what's going on. Know how your Java applications, or any applications really, are using the memory that you're giving to them. Observe them with whatever tooling your organization has. Adjust along the way so that you're not spending money you don't need to, but at the same time so you're not having your pods get killed because you're under provisioned. I've listed a couple good articles that kind of helped out when we were going through this. I'll post these on the Slack channel for those of you who might be interested in reading those. That's all I have. So if you have any questions, that's my email if you want to email me, or feel free to talk to me one of the breaks with questions or comments. I'd love to hear if anybody's running Java 10 or 11, what your experiences are. We have we got the magic mic. What's that? Turn mine off? Okay.
This is on. There we go. All right. My question was just, do you think it's better to have Kubernetes spin up more pods to handle a load than it is to have them scale the pods to handle the load? So if you have a really memory intensive operation, instead of having one pod that bloats up to use a ton of resources to handle that, is it better to just bring up 2, 3, 4 more pods to handle that workload?
Yep, I'm back on, right? Sweet. I can figure this out. I think in general you want to scale horizontally. So distribute your workloads across multiple nodes. That way if you have a problem with any particular node, you're not dead in the water because you've allocated one pod with 8 gig of memory instead of 4 pods with 2 gig of memory. It depends on the type of work being done. If you need, maybe you're consuming these humongous data sets that you need to allocate that much memory. But in general, I think you want to horizontally scale wherever possible. Anybody else want to comment on that? Okay. Any other questions? And if you have any other questions, feel free to hit me up during we're going to do a break now, is that correct?
Yeah, break until 7:20. So grab something to drink, maybe some more food, and hopefully gather everyone on topic space and have a chat.
Thanks, everyone.
Can you hear me? Yes. You can hear that? How about now? Is that better? Pretty good? Okay, so we're running a couple of minutes behind, but I can go nice and fast with this one. So Istio, instant Istio at that, just add YAML. So all we're going to be really doing today is this really coming through good? Yeah. Okay, good. I'm going to walk through just going through an existing cluster that I have set up, bringing Istio into it. How many people have worked with Istio up to this point? Little? Yeah. So to me, it's one of the things that really brings me into the whole cloud native landscape is just the ability of that service mesh. Kubernetes is great and all. I mean, that's the basis of a lot of what we do. But Istio, I think, is really what brings up those higher level features that makes our applications more durable, fault tolerant, secure. visible. So I am by no means an expert at Istio, but I will try to walk us through this. So Istio defines itself, this is right off their page, as a open platform providing a uniform way to integrate microservices, manage traffic flow across microservices, enforces policies, aggregate telemetry data. Istio's control plane provides an abstraction layer over underlying cluster management platforms such as Kubernetes, Mesos, et cetera. Wow, that is quite the definition, and I really don't think it really explains what it does too good. So I tried to boil it down a little. And to me, what it really is, it adds infrastructure into our application. And that infrastructure, again, makes the application a little more fault tolerant, secure, observable, and testable. And I say it can do that because, is it a pick and choose thing at that point in time? There's many different ways to enable different features within it. And that's what we're going to try to do tonight. So I'm going to jump right into it, and I just have to warn you, when I was doing this earlier in the day, it was not going so good. Google, I'm using my own personal cluster on Google Cloud, and I've used preemptive instances, and they were preempting my instances for sure. Hopefully that's all worked out at this point in time. So what we're going to attempt here, I do have a little script in this. I do have out on my Bitbucket site, and I'll put a link to this out on the probably on the Meetup event, so anybody can come out here and walk through basically the same thing that we're doing today. So the prerequisites here, like I said, I do have a working cluster set up right now. So that is a prereq. I haven't tried this on Minikube. It should all work on Minikube the same way as it does here. Minus, you probably have to tweak a little how we do the ingress type stuff, because the ingress on the Minikube works a little different. Without further ado, a lot of this also I got off the Istio, their own docs and whatnot. Just sort of boiled it around down a little. So I start right up here from installing Istio itself, and like I said, it is 1.1.1 has been released at this point in time. I've already downloaded that, so we don't have to wait for that. So the first thing that you would do is go into your Istio directory, which I am in there, and just run. And there's YAML files embedded in their directory structure here, and this command will define all the custom resource definitions for Istio. And then they have this basically a setup to set up the, I should have showed you first, yeah. So my current application is just these 3 containers. They're all pretty much the same container, 2 running on the outside, 1 on the inside. This was empty before I did that. I was supposed to show that, but this is what it did that last script, is it made all the resources that it's going to need. Now this is going to take a couple of minutes to spin up, but after this is spun up, Istio is installed in your cluster, and what it'll do is by default it's going to install it into a namespace called Istio system. So all of these, as you can see up there, are the pods from Istio system. They'll all come up here, like I said, in a couple of minutes or so. The last one is usually the ingress and the egress ones there. But before we do that, we're going to look at my application a little. I'm not going to look at the code, but we're going to look at what it does. So this little application, it's a little Go application. I'm terrible at Go. So good thing I didn't have to do much with this one. All it does is it takes a request in that we can see here. And gives back a message back there. Now, I'm not a very good developer, as I said. So 1 out of every 10 times, the application returns an exception. And so of the pods that we saw over here, the inner one is being called by the outer one. So when that junk request first comes in, I have an ingress set up currently that'll go into the outer service, and that service goes to a deployment. That deployment it's got a scale of 2, so there's 2 containers that it can rotate back and forth with, and each one of those call the inner one. And so 10% of the time, these are going to fail. 10% of the time, that's going to fail when it turns around and calls that. So in total, as we let Apache JMeter go here, we'll see that that average will get up to about 80%. So hey, I think that's pretty good. You know, I'm in the prediction business, so maybe I'm in the weather business, right? So 80% of the time, really, really darn good. So that's what that's going to turn out to be. Both of those lines. So the obviously a 200 is one of the successful ones. The 418 is when the inner service fails, and the 500 is when the outer service fails. The inner really throws a 500 as well, but then the outer catches it and turns it into a 418. Now, I do have some extra Google Cloud shirts from the last event. So anybody that can tell me what a 418 is for an HTTP code. I'm a teapot, okay. See me afterwards and I'll grab you a t-shirt. So, yes, hopefully let's come over here and check these at this point. And we are looking like we are good. So we have Istio up and running. So what does that give us? It doesn't really give us much, just sitting there running. So what we have to do, and I do have these commands up there to check and what it should look like when it's all up and running. So what we have to do to enable it for ourselves is we have to put a label on our namespace. So Istio, well, I should state that the mode that I chose to install Istio in is and by default it will be, it'll inject the sidecar into any pod that is deployed out into our namespace, automatically do that. There is a command that if you don't want it to automatically do, you can pick and choose which pods you want it in, and you can do that. But it's certainly simpler to do that this way, and typically you want it in everywhere. But in order to do that, you have to label your namespace so it knows what namespaces it wants that sidecar injection on. So we're going to go ahead and do that. And my namespace, everything's in default. And so it's labeled. So now we have that running there, but it only can do that injection when a pod is entered into it, so when it's installed into it. So right now, you'd still see over here, all of my pods here just have one image in it. And that, if you don't know, that's what this number here is, how many images are actually running in that pod. So what I'm going to do here is just force a little restart of all of those. And it's going to do it in a nice little rolling deploy mode. And so it updated those, and as we jump over here, we can see it's going to fairly quickly bring up some new pods for us. And now you can see that they have 2 images inside of them, and hopefully, and it looks like they're coming up okay. So far, so good. So now with that, we have our sidecar injector. So Istio itself is a service mesh. It uses a product called Envoy, which is in turn itself a service mesh, but that's what the sidecar is here. It's an Envoy container, and what it'll do, it'll capture, whatever we want it to capture, coming in and out of the pod itself, and so that's where it puts all of its magic in. It's really just configuring that Envoy proxy at that point in time. Oops. So the first thing that we can do with that, just by default there, is we can, it installs a product which Branden and I were debating on what it's named. What you say? Kiali. Okay, I'll trust you on that. And so all I'm going to do here is open a port forward for this. And so go over to this and give a little refresh. Maybe I will. Timeout. See? Okay. Did you work? Hello. Still working. Time out. Let's look at our pods. We see it up here and running. Now, when I was saying I was having problems earlier in the day, this was not it. This came up every time. Okay, let's. Bind is already in use. Do I have that? Well, if I do, it's certainly not doing anything. Okay, so let's, instead of going, did I do that backwards? I always do that backwards. Once again. There we go. How about that? So just out of the box here, this is what it gives us. So we have some traffic coming in. It's coming into one of our outer, the triangles here are services. The boxes in this case are applications. If we go to a different view, say workloads, it'll be service or pods, but so this is where it all comes in, right? So we can see the traffic coming through here, and even better, we can add some labels onto this, and we can look at response time. So Go is supposed to be faster than that. It's not really that fast. But like I said, I'm not a good programmer. So we also have the percent of traffic that's coming through here, and again, that outer is always calling that inner, so it's 100% all the way through. But then my favorite label here is traffic per second, and it also gives you the error rate. So here we see that we're getting about 27 requests a second coming through here, and we see that it's still within my SLAs at a 19% failure rate. So hey, I'm still doing good. It will by default it will make this right now. You see it as orange. Anything over it tells us on the bottom down here. Anything over. Actually, it's in the legend. Anything over 0.1%, it's going to turn orange. Anything over 20%, it's going to turn red. You probably can't tell here, but it is orange, so I am still doing great. And here we get the icons down here for the different colors of what they mean and the node shapes and whatnot. So we can see our traffic coming into our application. So we didn't have to touch anything at this point. Everything's working just fine out of the box. So our next, the next thing that it installs for us, it installs Grafana. Grafana, has anybody used Grafana? Grafana is a fun little tool, but hopefully this one works better. But it gives us several dashboards here right out of the box. This is my favorite dashboard here. It's the service, so I can look at any of my services through here. Again, I have the two services, outer and inner. And what you see here is on the top here, you see what it looks like from the client coming into the service. And then lower on, it gives you the data from the service itself. You'll notice the inner one, we see data in both. The outer one, we lack this client data here, but we still see all the server information for that. We'll get into why in a little bit. But there's also other, you can get right into the mixer itself. People that are smarter than me will figure out what's there. Overall performance dashboard, we can see some CPUs, memory usage. So it gives us a lot of information, again, right out of the box without having to really do much of anything. And of course, my battery is 11 minutes remaining. Well, we're going to have to go quick here. Yeah, thanks, Steve. I don't know if you might need an extension cord, too. Okay, so here, we'll move it along a little faster. You were prepared? I obviously wasn't. Do you have a place to plug it into? Is there a spot down there? Okay. Yeah, plenty of time. Nothing like this would ever happen. Okay, so we have good data here so that we can see again. We didn't have to do any fancy setup or anything. Got it? Yeah. We're charging, doing good. Okay, so my product owner, I should have had Michael, one of my product owners is here. I should have had him come over and do this with me, but he decided he didn't want to be a teapot anymore. Nor did he want us to send that back to anybody, and he was a little shaky on the 80% rate. Okay, I'll see what I can do with that. I'll make sure that we don't return back I'm a teapot anymore, and maybe bump you up a few percent. And so one of the really cool things, that really excites me about the service mesh is just the ability to do that. Again, I'm not going into the application at all. I already told you I'm a horrible developer, but I can figure out configuration. And so what I'm going to do here is add in what Istio calls a virtual service. And this is one of those custom resource definitions that was loaded on in one of the earlier steps here. And what I'm going to do here is I'm going to basically say, give this a name, and I'm going to call this inner because I'm going to, do it to the inner service. Again, the host is going to be inner. It matches that name. That can be a fully qualified Kubernetes name at that point in time. And again, with the destination inner as well. And I'm going to retry those things 3 times. So I know my application, messes up, 1 every 10 times. So retrying that 3 times should make it happen without having to change anything else. And I'm going to retry on that 500. Like I said, I know that's returning to 500. It's being translated to a 418 when it's in the outer service. Another thing here, even though he didn't ask me to do, but every time it retries, I'm only going to wait 2 seconds. So if it goes any longer than that, it's going to cut off and retry again. And only after the 3 attempts, it would give a bad status code back. So I'm going to take this. I'm not going to fill in all that stuff. I do have, and I'll show you here. This is what the YAML looks like all filled out. It's got that inner in there. So all I'm going to do is apply that. Have a little alias for kubectl apply. And so, bang, just like that. So one of the things that happened right away when we did that is this tool saw it. So right now it gave a little symbol, and you can see the little symbol down here. You probably can't read it too good from the back. But it's saying that this is now a virtual service. So we turned that, what was a service in our normal Kubernetes deployment into a virtual service. And one of the really neat things with this application here is I can now go into the config on here, and I can even look at that YAML directly out of this tool, and even more so, I can edit it from here as well if I really felt like it. But for right now, that is happening. And if we go back and look at this graph, all of a sudden we see our rate here of bad ones go down. We're down to 2%, and this is, let's update that every 5 seconds. This is, by default, it's the last minute. Every 15 seconds, we'll go down to every 5. And eventually, this will, there we go, it turns green. So now, all of those requests, even though there's some bad requests that are happening within the server, those are still happening, but it's retrying those up to 3 times, and my outer service never knows the difference. It's always getting a good one, a good request coming back here, and we can see on our chart here, towards the end, you can see the pink line that was the 418. We no longer get that line. So we've increased our success rate by 10% at this point. Life is good. So Michael's happy.
What does that do to the timing?
Yeah, I mean, it does it consecutively. So each time it's called, it would. Again, this was only happening 1 out of every 10 times. So you're probably getting 2 requests on that 1 out of 10 times.
Or you can see like the milliseconds, does that go up a little bit?
Yeah, you would see that. Right now, I don't have the tracing set up, and to see the actual call, when you have that actual call, you would see that trace, you'd see that those 2 calls, and yes, you would see both of those service calls in there. So, anyways, Michael decided that, that was really cool, and he wanted me to. He doesn't want any 500s now, and he wants closer to 100%. I keep telling him there's no such thing as 100%. He never believes me. So, okay, we can do this same thing. And again, we can make another virtual service here. Looks identical to the last one, has outer, outer, outer. I'm going to go ahead and apply that as well. And again, on our console here, we see that it got that virtual service in here. But lo and behold, we can go back over to Apache, and for some reason, we're still getting those 500s. And they're not going to go away right now. So I did the same thing. What happened? Well, what happens is the retry happens over here, not over here. So right now, Istio doesn't know about that incoming request. It's coming from my normal ingress. In fact, I can show you the normal ingress that I have configured for that. It's normal Kubernetes ingress. Again, it's going on the path of junk, and it's going to my outer service name. But Istio doesn't capture that at that point, so it can't get in there to do the retry at this point. So as Branden mentioned, and it's one of the things that went GA in this last release is the Istio gateway. So we have to make a gateway in Istio to actually get that traffic on the inbound, and so that the Istio can see that and actually do the retries. Now, the unfortunate part of this is, the ingress is attached to in this case right now I'm using the GCP, so it's attached to an external load balancer at GCP. And so the Istio gateway will create its own load balancer and be attached to that. So what that means is I will have to switch IP addresses now to hit the gateway versus hitting the default ingress. And so with that, there's a couple of configurations that have to go on here. So one, like I said, we have to define a gateway. And this we can give whatever name that we want. But our selector here is we select the ingress gateway. And that was one of the pods that we saw defined right in here. It was part of that initial install for things. So that's what we're pointing at for that. Doing the, going on port 80, blah, blah, blah. We're going to do all hosts. In a production environment, obviously, you would put whatever hosts you have in there. But then we have to make some changes to our virtual service that we already put around the outer. And what we have to do is, again, this would be that. A lot of this stuff matches up with what you saw in the ingress, because, again, we're sort of replacing what we're doing with the ingress on this virtual service now. So again, this would be like the external host that it's come on. Again, we're going to do a star for this. We're going to point up to the gateway name that we we're going to define up there. And here again, we're going to have to put our path in here, so it serves us that. Most everything else here is the same as it was before. So let's go back over there and go ahead and apply that. So that was the gateway, and then the outer that's looking at the gateway, I'll apply that over the top of it as well. Now the funny thing is, I don't know if this is a bug or not. Well, I'm pretty sure it probably is. For whatever reason, when you apply that gateway into that virtual service, now on this view, it doesn't look like a virtual service anymore, but I assure you, when you go in here and look at it, it's still a virtual service, and you can still see all the YAML and everything. But you see those changes now that we made in here, and you can also see the gateway in here as well. So if you wanted to make changes to that again directly. Now our graph has not changed to this point because, again, like I said, all of our load is coming in through the ingress still. It doesn't get rid of that ingress as you do that. And let's see if it changed IP addresses on me. Oh, it did not change IP addresses on me. Okay, so this is our new IP address. This is for the Istio gateway. And so what I'm going to do here now is stop my JMeter. I'm going to add this address there. And now when we come through that gateway, here, let me be easier to see. Look at that, we're getting all 200s now. Again, without changing any of that very good code. And if we go back into, how do you say it again? Kalili, Kalala, Kalhuluhu. Yeah, so now we see our gateway that's coming in here, and we can see it's defined for us that it's coming in. Why do we have these? Well, apparently last night I left JMeter running at my house, and so these are still coming in through the gateway from my house. But I assure you that all the traffic that we're sending through here right now is coming through the gateway here, and we see a nice green line coming through this path. So now everybody is happy, and I'm working at close to 100% here. Michael's happy. And again, I didn't have to touch a bit of code to be able to do this. All configuration up to this point. So other things, I mean, I will, in future months or whatever, probably expand on this because there are so many other things. But one of the other things, a couple of the other things I did want to show you yet tonight, and I know we're pushing up against time here a little, but I'll be nice and quick, is injecting faults. Well, I just took out all the faults. Why would I want to put some faults back into my application? Well, that's just the way I am. Never want to give anybody perfect. So in reality, this is used for chaos testing, right? So you inject faults into your system, typically your production systems, to try to figure out what it does into the system. So in this case, I'm going to work with my virtual service here, and this will be my inner one that I do this with, and I'm going to add a delay here of 7 seconds for 20% of the requests that come in, and I'm also going to get a status of 409, because I don't know what my application does when I get a 409. And I'm going to also do that 20% of the time. I'm going to do that for the inner one. So yeah, the outer will be calling the inner at that point in time. So, and we can look at what that looks like. And again, everything looks the same. I just added this fault section in at this point in time. So again, I will apply that into my application, and now let's see what it does. In fact, we'll look at both of these at the same time. And wow, it looks like my application slowed down a little bit. And look at that, I'm getting some 418s again. We're back to being a teapot. So it didn't matter if it was really a 500 coming from my inner one to my outer one. I was apparently catching any bad status or maybe anything other than 200 and returning that back as a 418, even though I'm given a 419 from there. But within there, which is what's really interesting, you can see that the service itself is actually still working fine, right? The inner service, not a problem, but 20% of the time it's returning a bad request back there. So we can do that all day long. We can make things bad and good and just do those little tests in production. So now I know what's really going to happen when a 418 when I return a 409 from the inner service. I also know if I have an occasional 7-second delay, it really hurts my requests per second. So Mike will find out about that, and he said, stop doing that. Okay, I'll put it back. And so just as fast as we put it in there, we can take that back, and you can see that those 418s stopped, and we're climbing back up for that. So pretty cool. I may have time to show you the one last thing. The one last thing isn't as cool as this one, but. So the last thing out here is whitelisting and blacklisting. So based on, just like you might, normally do in a firewall, you might want to whitelist some IP addresses, or even more likely, maybe blacklist some IP addresses, come from a source that that you don't really want to come into your system, some sort of previous attack that you had or whatnot. So you can do that, again, right through the service mesh. It takes 3 different resources to be able to do that. The first one, we're just defining the list of IP addresses. In this case, I'll do 1, and I'll do the one for our building here. Blacklist faults, which means I'm really going to whitelist that IP address. The second resource here is just grabbing off of the request coming through, saying what source IP address that's coming from, so I can eventually compare it to the IP address there. And the bottom here is what puts it all together. It's the actual rule itself. Again, you give it a name, and then getting the source off of that. So again, what that looks like. Is those 3. I'm taking this IP address. Again, that section looks the same, this section looks the same. So I'll apply that. And now, because that IP address was whitelisted, everything else is essentially blacklisted. So only traffic can come in from there. If I go up and hit off of my ingress, everything is fine, everything's cool. Oh no, it's not. So I use the IP address of our building here, but really that's coming in through that gateway point. And so this is an internal IP address that it's coming from that I should have had on there. So now it really denied me for absolutely everything. So, but this is what you would get. So you could see this, and again, it's like putting a firewall rule in, but again, you're doing it through your application configuration. And I think that's the point of the service mesh, is it brings a lot of those things that were, maybe your traditional infrastructure, or maybe even, in your application stack. I mean, you could have easily coded in some retries within the application itself, but how many times are you going to do that? For every application, are you going to do that? Okay, so you have a library, then you have to keep that library updated or whatnot. This is a way that we can do it right through the platform itself instead of getting that into code. So less code, easier to test code, easier to understand code, but it brings us a lot of power, and we can apply this throughout our system, again, without touching any code, for people who can't code like me, but with this, just with some YAML. So that's what I have for you. Like I said, I'll put this post out there, and I do have these cleanup steps down here that'll remove everything that's out of here. Just a little plug for Google again. They were our sponsor last time. If you do want to, sign out, like I said, I have a personal account out on Google. You can sign up, and I think by default they give you like $300 of credit to use. Setting this all up and executing something like this does take actual money, but then you can spin it down, and you have like a year to spend that. So if you want to test that, or like I said, you can test the stuff with Minikube as well. So, any questions? Yeah. That's one of the things that we absolutely hope to do. We're still in the early stages right now of doing this, but yeah, like I said, there's a ton of stuff in here. Yeah, the traffic routing there, again, you can bring in X amount of traffic, put it over to your V2 part of that service. Again, capture metrics off of that, and then with a tool like Spinnaker or something like that, see if you want to continue that canary deploy out throughout the instance. That's absolutely what we intend on doing with it. It's just not going to be one of our first steps with it right now. Other questions? Yeah.
So a lot of the steps that we did in this case come off to me as being kind of boilerplatey, and I wonder if this is, if the same kind of feel extends to when you're working on production things, or does some of this kind of get hidden, or can you abstract that and apply it without having to write this for every application, or?
Yeah, I mean, it depends on the resources in there. I know, yeah, some of it certainly does feel like that. I think you might make different choices on different resources, but there are other ways of doing selectors and whatnot off of that as well to apply it a little more broad, depending upon the resource within the Istio mesh.
You can also build it in your chart or whatever you're using.
Yeah, and if you're using Helm charts, obviously, yeah, you can build it into that. So, yeah.
So going back to Steve's conversation about pods and resources, when you inject that Istio sideground with pods, are there any significant resource considerations you have to take into account for memory or CPU or anything?
Yeah, I mean, there's definitely resources that you have to account for when you do that. We're not to the point right now of measuring what that is, but there is going to be some, and like Branden mentioned early on, there is somewhat of an overhead, for those transactions coming back and forth out of that as well. But it is, it's in that same space, so it is a fairly low overhead. But yeah, there's memory resources that you have to figure out then for that as well.
They do publish out their release notes, so they'll say for 1,000 requests per second, this is what you can expect each one of the Istio components to consume at that standard throughput.
Anything else? Okay, well, thank you.